Motion is the change in the position of an object over time. As the car moves from left to right, its position changes. This is motion, described by the equation on the board. There are two main types of motion, linear and rotary. Linear motion happens when an object moves along a straight path. For example, a car on a road. Now, let's look at rotary motion. Rotary motion occurs when an object moves around a central point, like a wheel. This wheel shows rotary motion, turning around a central point. Rotary motion occurs when an object moves around a central point.
Wheel turning.
Unlike linear motion, which is straight, rotary motion is circular. Apart from linear motion, there are other types of motion we see in everyday life. Let's explore these other types of motion. Oscillatory motion is when an object moves back and forth repeatedly, like this pendulum, which swings back and forth rhythmically. Is this like a swing set?
Exactly, a perfect example.
Oscillatory motion is when something moves back and forth repeatedly, like a pendulum or a child on a swing. It's a common type of motion we see in everyday life. The particles move randomly, with no fixed path. Random motion is when movement has no fixed path or direction. So it's unpredictable? Exactly, each move is independent. For example, dust particles moving in the air. Notice the unpredictable movement. Can someone give an example?
Like leaves in the wind?
Exactly, their paths are random and hard to predict. Projectile motion is when an object moves in a curved path through the air. Like this ball on the board. See the curve?
Is that the trajectory?
Exactly. The trajectory is this curved path. It happens because of gravity pulling the object downward.
Why does it curve back down? Because gravity constantly pulls it towards.
So air resistance isn't a factor here? Circular motion is when an object moves in a circle. See the fan? It rotates in a perfect circle. Its speed is constant,
but its direction changes.
Exactly. Great question. Examples include a fan, a wheel, or a car on a circular track.
Is the speed constant?
Yes, the speed is constant, but the direction is always changing. You've learned oscillatory, random, projectile, and circular motion.
Oscillatory motion.
Like a spring moving up and down. Having boppertool. By circular motion. Speed is how fast something moves. It's the distance covered in a given time. Velocity includes direction. So, what's the difference?
Velocity has a direction.
Exactly. Velocity is speed in a specific direction. For example, 60 km/h to the east.
So velocity must include direction?
Exactly. Good questions, everyone. Keep thinking like that. Duration is when an object's velocity changes over time.
Like the car speeding up?
Exactly. The car speeds up here. We calculate it as change in velocity over time. Acceleration is when an object's velocity changes over time.
Can you show us an example?
Of course. Watch the car. It starts from rest and speeds positive acceleration. It also happens when an object slows down, like this car reducing speed.
So that's negative acceleration?
Exactly. The velocity decreases over time. Yes, we'll explore the equations of motion. These equations describe motion under constant acceleration. The equations of motion help us understand how objects move when they are subject to constant acceleration. This equation helps us find the final velocity of an object when we know its initial velocity, acceleration, and time. So here, how does time affect the final velocity? If the object starts from rest, the equation simplifies to v when at, making it easier to calculate the final velocity. So if it accelerates for 5 seconds, the final speed is 10 meters. Second makes a big difference. This equation calculates the displacement of an object by considering its initial velocity, acceleration, and time travel. Exactly. Watch the car. When the object starts from rest, u as 0, the equation simplifies to s's. This helps calculate the distance traveled under constant acceleration.
Can you give a quick sign?
This equation is useful when time is unknown. It uses displacement and acceleration. This equation allows us to calculate the final velocity when time isn't given, using like calculating velocity. That's a perfect example. This equation is useful when time is unknown. It helps calculate final velocity from displacement and acceleration, using initial velocity, acceleration, and displacement.
So it's for when you don't know the time?
Exactly. A straight line on a distance time graph indicates uniform motion at a constant speed. So it's always a straight. A straight line on a distance time graph shows uniform motion, where an object moves at a constant speed. The curved line on this graph shows acceleration.
How can we tell?
Notice how the slope gets steeper. The speed is increasing. The animation confirms this increase in velocity. The slope of a straight line on the distance time graph represents the speed of the object. Using the ruler, we can see the slope is constant, so the speed is constant. A straight line shows constant speed. And the curve? The curve shows acceleration.
So it's changing speed?
Exactly. The slope is changing. When the object's speed changes at different rates, the graph will curve, showing non-uniform motion.
So the steeper part means it's speeding up?
Exactly. The curve shows the changing speed. A straight line shows constant speed. And the curve? The curve shows acceleration.
So it's changing speed?
Exactly. The slope is changing. When the object's speed changes at different rates, the graph will curve, showing non-uniform motion.
So the steeper part means it's speeding up?
Exactly. The curve shows the changing speed. In summary, these equations and graphs help us understand motion. Think about how equations of motion and distance-time graphs help us understand how objects move and how we can calculate their speed and velocity. Acceleration is all around us. Who can give me a real-life example?
Driving a car.
Exactly. When you press the gas pedal, the car accelerates, just like we've learned. Let's see this in action. Now, let's look at free-fall motion. Objects also experience free fall, like this upless apple dropping due to gravity.
Why does the apple fall straight down?
It's because gravity pulls it straight down. In summary, motion is all around us. These concepts apply whether you're walking, driving, or flying.
So it's like a change in position?
Exactly. Think about how motion applies to the world around you. Great job, everyone. That's it for today.
Thanks.
If you are blessed by this video, don't forget to like, share, comment, and subscribe. Thanks for watching.